Hey guys, so in this video we're going to start talking about fluids in motion or fluid flow. And the first thing we're going to cover is the distinction between real fluids and ideal fluids. Let's check it out. Alright, so the motion of fluids or the flow of fluids can get pretty complicated. It's actually an area that's still under active research in physics, but we're going to simplify things by using a model called ideal fluids. So the idea is that fluids are pretty complicated, but if we eliminate a ton of the complexities, the more complicated complexities of real fluids, you end up with something that's called ideal fluids. They don't exist, but they are a way to make things more manageable. Cool? And there's three things you should know. First, you should know that these fluids will always be, ideal fluids will always be incompressible. That's a simplification. Compressible means constant density. Remember, density has to do with how tightly packed molecules are. And in ideal fluids, that's going to be constant. In real fluids, molecules could get tighter or less dense, less tightly packed, depending on what's going on, okay? So incompressible, constant density, that simplifies things a bunch. The second thing you should know is that ideal fluids are always going to have what's called laminar flow. And laminar flow just means steady flow. So if you look at water going through a pipe, if it's, let's say, a see-through pipe or something like that, you would see that there's just a constant stream of water that looks very clean and neat, as opposed to real fluids that could have what's called turbulent flow. Turbulent flow. Or turbulence. You could have turbulence if the liquid is moving, or the fluid more generally is moving too fast. Okay, so imagine if water is going way too fast and it goes through a little clot type thing here, some sort of constriction, then it could be that the water starts going all over the place, and this is turbulence, and this is generally bad news. Lucky for you, you're probably not going to see any turbulence questions. You may just have to know this conceptually. Cool. And the third distinction between them, and I'm going to start over here, is whether this motion is going to have viscosity, whether the fluid is going to have viscosity or not. Okay, so the defining characteristic, this is the most important of the three here, the defining characteristic of real fluids is that they have what's called viscous flow. Viscous flow. In other words, the liquid has viscosity. And viscosity has to do with the thickness of the fluid. So for example, honey, right? If you get a cup full of honey and you turn it like this, it's going to move very, very slowly. It's because it has a lot of viscosity. Ideal fluids have no viscosity at all. They have no resistance. Viscosity is essentially fluid friction. It's essentially fluid friction. And it works very similar to air resistance or kinetic friction in that it slows it down. Okay, so real fluids could have viscosity, and they could have viscous friction. Ideal fluids are always going to have what's called non-viscous, not very creative name, non-viscous flow. In other words, no friction. So that's the big difference. If you have an ideal fluid, it's going to flow. It's going to flow smoothly with no friction. A real fluid could have turbulence, and it has viscosity. Okay. Now, lucky for you, most problems you see, and maybe even all of the problems you see, will be about ideal fluids. In fact, a lot of professors don't even get into real fluids, so if yours doesn't, your life is simpler. We're going to also assume ideal fluids unless something says explicitly that this is a real fluid, or if they refer to viscosity, which is fluid resistance, right? So if they say that there's some sort of viscosity, then that means there's resistance, which means it's a real, which now it means that you have a real fluid. In most real fluid problems, you're going to have viscosity because it's the defining characteristic, but you're not going to have turbulence, and you're also not going to have compression of the fluid. Okay, so you're really not going to see this most of the time. You're not going to see this most of the time, but you are going to see this quite a bit. So you're going to have no turbulence and no compression of the fluid. Okay, so really it's going to come down to whether or not it has viscosity. So that's a quick intro so you can know some of the terminology, and that's it. Let's keep going.